As you will remember from our previous lesson, we were returning the ownership of the string type by using tuples again to get the ownership from the function. We can use references instead. We show references with the ampersand symbol. Thus, the value is accessed without giving ownership to the function. This event is called borrowing, and our variable survives throughout its scope even if its scope expires after the function has performed its task. You can think of it like lending a book to your friend. You are the original owner of the book and your friend returns it to you after they are done with the book. We can think of the reference as a pointer to the address of the value in memory, but the data belongs to another variable. We can describe it as a beacon that we can follow to access data. However, unlike a pointer, in Rust, the reference is guaranteed to point to a valid value of a certain type for its lifetime. Two important rules have been established to manage the behavior of references. First, at any given time, you can have either one mutable reference or any number of immutable references. The second is references should always be valid. Now, let's edit the code we processed in the ownership lesson in accordance with the reference rules and run it again. As you can see, our code worked without the need to transfer ownership. Do not forget that we put the ampersand symbol in the parameter part of our function. Let's examine our code by looking at the image that shows the logic of the reference. Here, the reference S actually points to the variable S1. Of course, it helps us reach some values without taking any ownership. We just mentioned the rule that references must point to a valid value. In languages with pointers, it's easy to accidentally create dangling pointers by freeing up some memory and putting a pointer in that memory. In contrast, the Rust compiler guarantees that references will never be dangling references. If you have a reference to some data, the compiler ensures that the data does not go out of scope before the reference to the data. Let's try to create a dangling reference to see how Rust logs them with a compiler time error. Since S is created inside the dangle function, when the dangle code is finished, the variable S will be released. But we try to return a reference to the released variable. This means that the reference will point to an invalid string. This is obviously a very bad memory safe bug, and Rust won't let us do it. The solution here is to return the string directly. Now your code works without any issues. Ownership is moved and nothing is reallocated.